show that R3 spans vectors one, 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 negative one, negative one, one, one.
This is section 2.3.
Are you filming? Well, I guess we are. Okay, so this is the problem. So we need to show that these three vectors can describe any vector in R3. Okay, so what this is really saying is that we can have a constant C1 times U1 plus C2 times U2 plus C3 times U3 equals a vector V in R3. So we can form a linear combination of U1, U2, and U3 to form any vector in R3. So we can construct a matrix. So we can say that 1, 1, 1, 1, 1, negative 1, negative 1, 1, 1 equal the first component of V1, the first component of V, which is V1, the second component of V, which is V2, and the third component of V, which is V3. And these are vectors U1, U2, and U3. So we want to find vectors so that this matrix is true. So we can perform row echelon operations. So first one we can do is we can do R1 minus R2. So we get a 0, another 0, and negative 2. We get V1 minus V2. And then we get the third row, just the same. Okay. Now we can do R1 minus R3. It's not minus.
Put the vector over there.
What's that? Okay.
Keep it up.
I'm sorry.
Doing great.
0. This is 2 and minus 2. This is V1 minus V2 and V1 minus V3. And now to put it back into row echelon form, we can flip. Sorry. We can flip the second and third rows. So put it back.
Yeah, you can.
Yeah, you can.
Do it.
This is in English class.
V1 minus V3 and 0, 2 minus, no, that's the same run. 0, 2, V1 minus V2.
It's
Alright,
supposed to be a negative 2 on the bottom.
oh it is. My bad. Okay, so this is in row echelon form. So we can see that for any V1 and V2, we can actually have solutions of the matrix. Because even when V1 minus V2 is 0, the rank of A, which is this matrix, and the rank of B, which is the whole thing, is equal to each other. So in this condition, we have rank of A is equal to rank of B, which is also equal to the number of unknowns. We know that for any V1, V2, and V3, we will have a unique solution that will span all of R3. So now I think it's constructive to look at a case where a set of vectors won't span all of R3. So I'm going to erase all of this.
I'm excited.
Can't wait. Woo.
I have a pretty good class, so enthusiastic.
Carl Jung action figure. Intermission. Come on, John. Give me something in for intermission.
Man. Alright, so let's say we have three vectors. U1 is equal to 1, 0, 1. U2 is equal to 2, 3, 0. And then U3 is equal to 4, 6, and 2. Now I want to show that if these three vectors span all of our three, we need to make the same matrix as we made it in the previous problem. So we will have a matrix of 1, 0, 1, 2, 3, 0, and 4, 6, and 2. And this should equal the components of V, V1, V2, and V3. So now we can perform row echelon operations. So we can do 3R1 minus 2R2. This will get me 1, 2, 4, V1, and we'll get 0, 0, and 12 minus 12 is 0. It will equal V1 minus 2V1 minus 2V2. And then we have the third row, 1, 0, 2, and
I
V3.
think that's 3v1, but still
Oh,
works.
I apologize.
You're forgiven.
And then we can do R1 minus R3. We get 1, 2, 4, V1. Second row stays the same. Then we get 0, 2, and 2. And it's equal to V1 minus V3. And now we can rearrange this matrix to get back into row echelon form, and the phone is ringing. 1, 2, 4. V1, 0, 2, 2. V1 minus V3. We have 0, 0, 0, 3, V1 minus 2, V2. So now we can see that the rank of A will not equal the rank of B. The rank of B won't equal the rank of A only if 3V1 minus 2V2 does not equal 0. If 3V1 minus 2V2 does equal 0, then we will have a unique solution for the matrix, which will mean that only vectors so that 3V1 minus 2V2 equals 0 will form a unique solution of this matrix. So the span of these three vectors will be the plane of this.
Well, we'd have an infinite amount of solutions. To it,
Yeah,
but
so again, in this case, we do have a infinite amount of solutions. So you kind of one can visualize this as being a plane in R3. So it won't span all of R3. And if you notice that U3 is actually a combination of U1 and U2. So that's a way that you could recognize if three vectors will span all of R3, or if they won't, is when one of the vectors is written as a combination as the other ones. So that's all about for span. I hope you enjoyed it, and please leave comments if you have any questions. Great, thank you.
We did it.